when we apply this distribution, sometimes we have to distribute where there's exponents involved. So you have to make sure that we're clear on our exponent properties. So when we are multiplying, okay, and we're multiplying like bases, we can add or count up the exponents. If we're dividing like bases, in this case base A, we can subtract the exponents because divide cancels out a multiply. So if I want to multiply this out, A7 times A2, this is all connected by multiplication, so I can write this as 1 exponent of 7 plus 2. Here I have y times y squared times y cubed. This is all connected by multiplication, so this is all base y. And I can count up 1 plus 2 is 3, plus 3 is 6. Here I can do the numbers with numbers, a's with a's, b's with b's. 10 over 2, we can simplify that to 5 over 2. Okay. Here we have 5 a's multiplied, 8 a's divide. Well, that means I have an extra 3 a's in division. And with the b's, we can do the opposite. We got 7 multiplied, 3 divide, so I have an extra 4 b's in multiplication. So I have b4 in the numerator, a cubed in the denominator. Here we just make sure we group our a's together. So I have 2 a's here, 3 a's here. It's all connected by multiplication. So I have 5 a's multiplied in total. I have 1 b and 5 b's all connected by multiplication. So I can say I have 6 b's, and I can rearrange this and group the a's with the a's, b's with the b's. So this is the key part though. When we want to remove brackets, there's kind of 2 ways to do it. We're getting at this idea of distribution. Well, one way, if I want to calculate this, is I can just simply calculate this as do brackets first, do bedmass. 3, the brackets is 5 plus 2 is 7. And then 3 times 7 is 21. Perfectly fine. That's using bedmass. Okay, I'm just going to put down here bedmass. Now we can get around bedmass by doing this. Well, I can distribute. And I know that this is my length. This is my width here. Okay, so there's my length. There's my width. And I know this length is common to both pieces of width. So I can distribute that length to both parts. So I get 15 plus 6. And I can see that that's going to add up to the exact same area of 21. And this is no surprise because we know that distribution works. Okay? We know that it's going to give us a consistent area, and we know we have a picture in our mind of how it works. So this is using distribution. Now, really, there's no point in using distribution here because really we should apply bedmass. But when we can't apply bedmass, for example here, this is asking me to do brackets first. This is asking me to do the add before times. Well, I can't add a plus 2. Okay, we cannot group a's with 2's. We cannot count them the same. However, we can say that we have 3 groups of a plus 2. Well, if we have 3 groups of a plus 2, I can take that grouping to here and to here. The other way I can think of it is in a picture. When I draw a picture out of this, and this is the same picture I've had here, I know that this side length of 3 is shared with the a length and the plus 2 length, and we end up with 3a plus 6. Okay, so we can do this distribution. This distribution essentially is this area model. So we can see very clearly it's because it shares the same side length of 3 along the vertical for both parts of the a and the plus 2. So when we distribute this then, we just need to make sure we distribute out the brackets. So we get 5b plus 35. Okay. Here we're going to end up distributing this out. So we get 8 minus 4b. Okay, so what I would like you to do is I want you to pause this video and I want you to do these on your own and then come to the next video and you can check your answers. But I want you to practice this on your own, show the distribution lines as well, just to make sure you're clear physically what's going on with this.